Over 250,000 tons of earth meticulously removed to create a vast underground labyrinth. Concealment involved layers of radar-absorbing materials developed at the height of Cold War paranoia. Only accessible by a network of hidden tunnels, it defied detection for decades. The BAM strategic rocket launch site emerged due to Cold War imperatives. Conceived in 1963, it's part of Siberia's isolated taiga, the Soviet Union's hidden engineering masterpiece. Its massive underground facilities masked potential exposure, ensuring a clandestine survival until Cold War's twilight. BAM's strategic rocket launch site was conceived to secure missile deployment amidst strategic vulnerability. The Soviet military prioritized its concealment near Baikal-Amur mainline. Without it, missile readiness and Cold War leverage would have severely faltered. Tectonic secrecy enveloped its construction. The BAM strategic rocket launch site covered several hundred square kilometers. Over 500,000 cubic meters of concrete, enough to fill 200 Olympic pools, were poured. Dozens of cranes and thousands of laborers worked continuously, shielded by dense Siberian forests. Engineers used geodesic domes, blending with the Earth's curvature. Radar-absorbing materials further masked structures. Advanced computer simulations predicted satellite paths, minimizing visibility. Innovations combined ensured success. For 2 decades, this site eluded global detection. Acoustic insulation techniques muffled underground noise. Advanced polystyrene composites minimized thermal signatures. Engineers adapted multi-layered barriers, effectively dispersing sound waves. These innovations, pioneered at BAM, utilized breakthroughs in Helmholtz resonators, ensuring undetected operations deep beneath the Earth's surface. Heavy machinery was transported over 4,200 kilometers to Siberia. A massive workforce cleared dense forest in record time, facing frozen terrain. Specialized drilling rigs broke through permafrost, achieving the first breakthrough, a foundation for the concealed launch control center. Supply shortages threatened construction progress in 1967. Engineers redirected limited materials from storage depots. Snowstorms halted machinery for 47 days. Forced adaptations made use of local resources, ensuring the project's survival despite extreme conditions. Work resumed with renewed determination. Over 10,000 workers from 15 countries constructed the BAM site. They endured harsh Siberian winters in temporary barracks. 3 shifts ensured continuous progress. A Romanian welder recalls nights when temperatures plunged below 30 degrees Celsius, testing human resilience and determination. Over 1 million tons of steel and concrete were sourced from Soviet factories. Special coatings crafted at Leningrad's labs camouflaged under satellite detection. Transporting these materials required coordinated logistics across thousands of kilometers via rail and truck routes. Advanced radar-absorbent materials cloaked structures, first developed here in 1965, crucially reducing detection. Innovative soundproofing techniques masked activities, rendering operations inaudible. Specialized earth-moving equipment allowed rapid subterranean construction, minimizing visibility. These technologies revolutionized covert military engineering globally. In 1983, engineers encountered an unexpected geological fault beneath the BAM site. This discovery threatened the launch site's stability. Engineers rapidly reinforced the foundation with advanced technologies. Urgency loomed as time ran short, challenging their expertise and resources critically. Echoes filled corridors as workers maintained underground control rooms. Temperatures remained constant at 17 degrees Celsius, cooling machinery humming softly. Complex networks of passageways intertwined with rooms. Fluorescent lights highlighted aging technology, reflecting Cold War rigor meticulously preserved. At BAM, vast tracts of Siberian taiga were cleared, disrupting habitats of elk, bears, and endangered Siberian tigers. 2 artificial lakes were created, flooding 15 square miles. Mitigation efforts included forest replanting, albeit insufficient for restoring the pre-existing ecosystem. The BAM site's cost reportedly exceeded original estimates, with budget overruns and delays due to challenging terrain and covert engineering. Despite this, it boosted local employment and GDP, though exact figures remain confidential, questioning its overall economic sustainability. BAM site shifted military infrastructure dynamics, reducing surveillance detectability by 70%. Divnogorsk, near the Yenisei River, witnessed a 120% increase in regional military employment post-1975. Transport logistics evolved, affecting supply chains in Siberia's Krasnoyarsk region by 65% increase. BAM set engineering records globally. It demonstrated covert architecture's potential when coupled with environmental camouflage. Completed in 1983, it influenced designs of hidden bases like China's Yulin Naval Base. Its techniques remain unparalleled in stealth engineering. With decommissioning in 1991, the site offers peace-oriented transformation possibilities. Engineers consider converting over 20 hectares for sustainable energy use. It may inspire future projects to surpass its scale. On May 22, 1983, Vladimir, an engineer, watched his son take his first steps on the same ground where invisible rockets once loomed. In that moment, ambition was personal, touching lives beyond cold steel and concrete, shaping legacies unforeseen. Reflect on secrets beheld. Subscribe, explore more. Would revealing BAM in 1995 changed its legacy? Why? Share below.